Ah, at last, an inclined plane problem with friction on it, something worthy of you. Okay. What we do before you can solve this problem, there's 4 different things we've got to calculate, right? We don't actually have to calculate this. We can kind of leapfrog over it, but let's just go with it. Okay, so the parallel force is just mg sine theta, right? So that is 5 times 9.81 times sine of 32. Okay. So 5 times 9.81 times sine of 32. I'm going to store that in A just for fun. And you get 25.993, roughly. Okay? Okay, this is a force that acts always down the plane. Okay? If you are doing any F equals ma, this guy's there, it's always down the plane, it's always negative. Okay? So now let's figure out the perpendicular component of gravity. That'll be our next thing. Okay, so force perpendicular is just mg cos theta, right? So that's going to be 5 times 9.81 times cos 32. And this guy really isn't a player in F equals ma, but it's going to give rise to friction, so we got to calculate it. So 5 times 9.81 times cos 32. I'm going to store that in B just for fun. That's 41.597. 41.597. Okay? It's just a force that we're going to use to calculate the forces of friction. Okay? We're going to use that thing to calculate the force of friction. So this, I agree with this. I agree with that one there. Okay, so now let's find for fun, let's find the maximum static friction. Right, these are easy. They're just force of friction is mu times the normal force. And because the plane is tilted, not all of gravity is into the plane, just some of it is, right? So this becomes our normal force. Okay? That's the normal force. That's what we use for here. We don't use m times g anymore. We got to use less than that. This is the part of gravity that's now giving rise to friction. So the maximum static, all we do is we use that that coefficient right there. So 0.670. We multiply by 41.597. Right? Times 0.67. And I get 27.870. 27.870 newtons of force. Okay? Now, that force, that thing that we just figured out, this guy is just simply going to try to make that thing sit still on the plane. It's never used in F equals ma because if it's moving, it's not, if it's accelerating or moving, it's not there anymore. It's the kinetic friction, right? So let's figure out the kinetic friction. Let's see, 27.87. I would have to say that that is actually 27.9. Okay? So kinetic friction is going to be mu times the normal force, right? Right, so then we just use this guy here. And this guy's going to be a player on our F equals ma. So 0.34, right, times our same thing, right? 41.597. So this force here, this perpendicular force, right, it's what we use for the normal force on these things, right? Okay, so alpha B is where I stored that guy times 0.34. I get 14.143. Okay, now let me just tell you this, okay? This parallel force right here, this is one of our players. That guy's going to always be down the plane. This guy here is always in your F equals ma. If it's moving along that plane, then this guy is there, okay? And this just, the kinetic friction opposes the velocity. So if you're sliding up the plane, this guy will be down the plane. If you're sliding down the plane, this guy will be up the plane. Okay, so this guy's a switch hitter. It's either up or down the plane, depending on which way you're sliding. just going to be opposite your velocity. Okay. Now we're going to use this value and this value here, and maybe this value later on in the videos here. We're going to use a more accurate version of it. I've stored it on my calculator. I highly recommend you do the same thing when you're doing these problems.